Hello guys, welcome back to our channel. Today we are going to see what is a full subtractor and how to design it and how to design this full subtractor using the Verilog. So we in the previous videos we see how a full adder is designed and how it performed. In the same way the full subtractor will also work as the full adder, but there is only a small difference between the full adder and the full subtractor. Let's see what is the difference between the full adder and the full subtractor in the block diagram or logic diagram. So in this logic diagram, obviously in the full adder what we required, two XOR gates, two AND gates and one OR gate. In the same way in the full subtractor also we require two XOR gates, two AND gates and one OR gate. So for that I am taking the two XOR gates. Here I am taking another XOR gate and two AND gates and finally one OR gate. Yeah, here we are giving the two inputs A comma B. Here we have to give the third input, right? In this I am considering it as a B in, but nothing but the borrow in. In the full adder we take the C in, right? In the full subtractor I am taking the B in. You can take anything. So here the major difference in this is we have to connect a inverter for the first input of the AND gate. In the full adder there will be no inverters in the AND gate, but in the full subtractor we have to connect the NOT gate to perform. The full subtractor will work as a the full adder will work as a full subtractor. So the B will be connected to the, as usually, to the AND gate. Here for the first A and B we got the first difference. In this we are considering it as a D, and this will be applied to the second XOR gate. Here we will get the first B out, see nothing but the bar out, and here finally here we get the final data, and here also we connecting a one NOT gate in this, and finally these two given to this, and we will finally got the borrow of the given expression. Okay, now we will see the truth table for this full subtractor. For that we require three inputs A, B and the B in, and the data and the borrow. The possible combinations here are 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 0 1 1 1. These are all the possible combinations for our full subtractor. So what's up here, we perform the subtraction operation, so the data and the borrow will be 0, all the zeros. Here only 1 is there, so the data will be 1 and the borrow will be 1. Here also same way, 0 and the 1, and here are the two ones, so the output will be 0 and the borrow will be 1, and here the data will be 1 and the borrow will be 0, and here the data will be 0 and the borrow also 0. Here also same way, and here 1 1. In this way the truth table for the full subtractor right. Now we have to find out what are the expressions for the data and what are the expressions for the borrow. So for that we can find out using the K-maps. So for that I am taking the one K-map for the data and another for firstly we will find out the expression for the data, and in shortcut I am considering it as a D. So here you can see that here in this side I am considering C, in the B and the B in. These are all the possible inputs. So I am drawing the K map. Here 0, here 1, 0 0 0 1 1 1 1 0. So nothing but it is a SOP form, that is nothing but the sum of the products. So for that B bar, B in bar, here B bar, B in, here B and the B in, here B and the B in bar, here A bar and A, here we can write the 0 1 3 2. In this way the order will be there. That's why here you can see that there is nothing but the 0 1 2 3 4 5 6 7. Here we have to write where are the 1 is the present. In this the ones are present at the 1 2 and 4 and finally 7. So 1 2 and 4 and finally 7. Here there are no possible connections are there, so I am writing the expression D is equal to, here first here A and upside B bar B in bar plus here A bar B bar B in plus here A and the B in A B B in, and finally here last one is there A bar B in bar. So this is the expression for the D. In shortcut we can write it as A XOR B XOR B in. Okay, right? And now for the borrow also I am considering another K map in the same way. Yes, you can see that here in the same way we have to see where are the number of the ones in the present. Here in this one and this one and this one. So where are this present? 1 2 3 and 7. So at there 1 2 3 and 7, remaining all are zeros. So the possible combinations are there in this one and this one and this 3 1. So we can write the expression for this. So borrow is equal to, so first one is there, these two, in these two the common are A bar and upside the common is B in. So A bar B in plus in this way there are no common in left side, so and the common at the upside B in and plus, and here A bar and upside B. So these are the expressions for the data and the borrow. Now let's see how to make the Verilog code for this full subtractor. Okay, now let's start the making the Verilog code for the full subtractor. So for that I am creating the module with the name called so for full subtractor, and I am taking the inputs input A comma B in, and for the output is nothing but the D comma bar it, and I'm closing this module. Now I'm assigning the function for the D and the B. As we know that we derived the expression for the data and the borrow. So for the D, the expression is nothing but the XOR operation between the three inputs. So A XOR B XOR B in, right? And for the borrow, the expression is complement A and is nothing but the multiplication B mortgage B and B in, and A complement B. So this is the operation, this is the expression for the borrow. So this is the design code for the full subtractor. So ending this module with the syntax called end module. Now let's write the test bench. So module pb register a comma b in while nothing but the outputs are d comma arrow, and I'm giving the full sub, and I'm giving all the inputs a comma b in and b comma borrow. So I'm starting giving the test bench initial begin dollar num file.vcd and next dump files. Yes, and next I am giving the test bench a equals 0, b equals 0, and b equal to also 0, and hash file is nothing but the delay. I'm just copying this to give the further values. So a 0 0 0 1 0 1 0 0 1 1. So these are sufficient to verify the functionality of the full subtractor. So I'm stopping this test bench by giving the command called finish and end, and finally end module. So this is the test bench for our design code of the full subtractor, and this is the design code. Now I am giving the title and also selecting the tools and the simulators. Okay, right? I'm opening preview and I am giving the title called full subtractor. Right? I'm saving this file and I'm going to run this. So I'm going to save this and I'm going to run this. Okay, we have to wait for a second. As the file is running, as this is the output. Here you can see that according to the truth table, here A, B, and the B are 0, 0, 1. So the sum and the data and the carry is also 1 and the 1. And you can verify this also using the truth table. And this is the process to design and verify the full subtractor using the Verilog. Thank you for watching this video. If you have any doubts, please mention in the comment section and stay tuned for the next video.